Hey guys, Mr. Backerberg here. In this video, we're going to be looking at functions as rules and tables. Now, before we get into what a function actually is, I've got just a couple of vocab words to take a look at. The first vocab word is domain, and that's the set of numbers which we're going to call our input values. We've also got something called the range, and those are the set of numbers that we're going to call our output values. And these domain and range values, these inputs and outputs, form ordered pairs. So we've got an input and we've got an output. So we can think about it as the domain and range, the input output, or we can also think about those as being independent and dependent values. So here I've got a table of values. The top row is labeled input values, and the second row is labeled output values. And we're asked to identify the domain and the range of the function. So we said that the domain was related to the input values. So the domain consists of the numbers 0, 1, 2, and 3. That set of numbers is our domain. Now, as far as the range goes, that set of numbers, those are going to come from our output values. So that includes 5. Now, 2 shows up twice, but I don't need to put 2 on my list twice. I can just put it on the list once. And then we've also got 1 in our range. So those values there, 5, 2, and 1, are part of the range because they're the output values. Those domain values came from the input. Another quick example, but it's the exact same type of thing. We've got some input values and we've got some output values. We're trying to identify the domain and the range. So the domain, we look at the input values. So we've got 2, 5, 6, and 8. And then for our range, we look at the output values. So we've got 14 on the list. 13 shows up twice, but I'm only going to write it down one time. And then we've also got 49. So that's our domain and range based on this table. Now this next example looks a little bit different. This is a function mapping. So we've still got input values and we've still got output values. When we're identifying the domain and range, we still do the exact same thing. For the domain, we look at the input values. So these are going to be my blue numbers on the left-hand side. 1, 2, 3, and 4. And as we look at the range, we've got the numbers 0, 1, and 2. So now we're going to talk about what a function actually is. And a function is a special rule or table or mapping where each input value is paired with exactly one output value. And you can think about a function like a machine. You input something specific and you get out something specific. Think about it like a vending machine. If you go to a vending machine and you hit the Pepsi button, you're hoping a Pepsi pops out. But if something else pops out, you would say, hey, this machine is broken and it's not working. So each time you put in an input, you need to get back exactly one output value. So now we're going to look at trying to decide if pairings represent functions. So we're going to look at the inputs and we're going to look at how many things they're matched with as far as the output values. So here as we look at the input values on this mapping, this input value of 4 is mapped over to 1. Okay, 4 is matched up with one thing. 8 is matched over with 3. So 8 is matched with only one thing, and 2 gets matched with 2. So each of my input values maps to only one output value. So yes, this does represent a function. Now if we look at our next example over here, we've got a table of input and output values. So we've got an input value of 2 and its output value is 2. But then we've got another input value of 2, but this time the output is 4. Our input value of 3 is matched with 6 and our input value of 4 is matched with 8. Trying to decide if this one is a function or not, we're looking to see to make sure that each input value is matched up with only one output value. And what we need to be careful of is with these two input values of 2. The first time we plugged in 2, we got 2 as an answer, but the second time we plugged in 2, we got 4. So because this input value of 2 is being matched with 2 different output values, this one is not a function. So we've got another mapping example, and we're trying to decide if this represents a function. So we're checking our input values to see how many different things they're mapped to as far as output values. And what we need to focus on is this 0 right here. Because notice 0 is getting mapped to 2, but 0 is also getting mapped to 3. So because we have an input value being mapped to two different output values, that makes this one not a function. So no, this does not represent a function. Now, algebraically, functions are often represented with equations. So we've got this equation y equals x plus 1. And we're asked to make a table for this function using domain values of 0, 2, 3, and 6. So these are going to be my input values. And we're trying to determine what our output values are. Now, as we're using this equation, your input values are going to be your x values. So we're going to be taking these 4 different numbers and plugging them in for x. And then your output values are going to be your answers that you get, or your y values. So if we plug in 0, we would get y equals 0 plus 1, and 0 plus 1 gives us 1 as an answer. So the input value of 0 gave me an output value of 1. If I plug in 2 for my x value, we'd get y equals 2 plus 1. 2 plus 1 is 3, so the output value for 2 is 3. If I plug in 3, so y equals 3 plus 1, we get an answer of 4. So we input 3, the output was 4, and then our last input value is 6. So y equals 6 plus 1, and 6 plus 1 is 7. So when we input 6, we got 7 as our answer. Now it does ask us to identify the range, and remember the range is associated with your output values. So I'm going to say that my range is the set of numbers 1, 3, 4, and 7. Another rule here, we've got y equals 2x. We're going to make a table using these domain values, and then once we're all done plugging these values in, we're going to identify the range. So again, we're going to have some input values, and we called those x's on the last page, and we're also going to have some output values, and we called those our y value answers. We're supposed to plug in 0 first, so if I plug that in, y equals 2 times 0, well, 2 times 0 is 0. So that input value's output is also 0. If I plug in 2 for my x value, y equals 2 times 2, I get an output value of 4. If I plug in 5 for my input value, 2 times 5 is going to give me 10 as my output. And then lastly, we're supposed to plug in 7, and 2 times 7 is 14. So we plugged in 7, we got out 14. So the range here, again, range is the output values. That consists of 0, 4, 10, and 14. Now this next example is a little bit different. We want to try to write a rule for the function represented by this table. So we've got some input values. We've got 1, 4, 6, and 10. We've also got some output values, 3, 6, 8, and 12. Now we're going to use x to represent our input, and we're going to let y represent our output values. So like we just saw with the last couple examples, we're going to have some sort of y equals equation. So we want to try to figure out what it is that we're doing to these input values, what we're doing to these x values, in order to get our output values, or these y values. So we're trying to figure out how are we going from 1 to 3? How are we going from 4 to 6? From 6 to 8, and from 10 to 12? And what it looks like to me is it looks like we're taking whatever this input value is and adding 2 to it. So I'm going to write this as y equals the input value, the x value, and we're adding 2 to that input value. So we have the equation y equals x plus 2. Last example here is a word problem, and it says you're buying some concert tickets, and they cost $15 a piece. You can buy up to 6 tickets. So we want to write the amount in dollars that you're going to spend as a function of the number of tickets that you buy. We want to identify the independent and dependent variables, and then we also want to identify the domain and the range of the function. So we're trying to represent the amount of money that we're spending based on the number of tickets that we're buying. So as far as my variables go, I'm going to use an A value to represent the amount of money, and I'm going to use an N value to represent the number of tickets that I'm buying. So if we think about this, the tickets cost $15 a piece. So the amount of money that you're going to spend is going to be $15 times the number of tickets that you buy. So if we think about this, sort of like our y equals equations that we've seen up to this point, the x value was our input value, and we also called that our independent variable at the very beginning. And then our output values, or our y values, those were our dependent variables. So as we're looking at this equation here, n is the independent variable, and that capital A is the dependent variable. Now we're going to take this equation that we just wrote out and we're going to try to make a table. This says that you could buy up to 6 tickets. So on my table, my input values are going to start at 0 and then they're going to go up to 6. So 0, 1, 2, 3, 4, 5, 6. And then my output values depend on what number it is that we're plugging in. So remember, we're taking 15 times our n value, and our n values are the input values. So the first thing I'm going to do is plug in 0. So 15 times 0 should give me an output value of 0. If I plug in 1, well, 15 times 1 is 15, so I get 15 there. If I plug in 2 for that n value, 15 times 2 is going to give me an output value of 30. If I plug in 3 for that n value, 3 times that 15 is going to give me 45. If I plug in 4, 15 times 4 is 60. If I plug in 5, 15 times 5 gives me 75. And then if I plug in 6, so if I buy all 6 tickets that I'm able to buy, that's going to give me 90. Now the last thing we're asked to do here is identify the domain and range of the function. So I'm going to start with that domain. Remember, your domain is your input values. So that was the 0, 1, 2, 3, 4, 5, and 6 that we plugged in. Your range is your output values. So that's the 0, 15, 30, 45, 60, 75, and 90. Those are the answers that we got when we plugged in those input values. That's going to be it for this video. Thanks for watching.